Hello and thanks for using TickBoom. For this question I've been asked to help out with part 2 and part 3. So the facts of the question are that we've been given a probability density function, and that's used to model the lifespan of a termite, x, capital X being the random variable x, in weeks. Now the function is fx equals k bracket 36 minus x squared, and that's valid for x between 3 and 6, otherwise it's nothing. Now part 1 asked us to show that the value of k is 1 on 45, but the student who sent through this question doesn't need help with that, so we're going to take that as given and then go straight into part 2, which is to find the cumulative distribution function, and then part 3, which is to find the probability that a termite's lifespan is greater than 5 weeks. So if we start by just writing out our probability density function, so our PDF, that's been provided to us as fx is equal to k 36 minus x squared, where x is between 3 and 6. So part 1 of the question was to prove that k was equal to 1 on 45, but as I mentioned, we'll take that as given. The student doesn't need help with that. So we get straight into part 2, which is to find the cumulative distribution function, which is defined as the probability that our random variable takes a value less than or equal to any value. So here it's the probability that our random variable capital X takes a value less than or equal to lowercase x, being whatever value where we know x is between 3 and 6. So that is worked out by finding the integral of our function. Now because I'm using x, it's basically the integral from negative infinity up to x of our function. Now just to make sure we're not confused between our x's, I'll write here fu to du. So we're going to integrate our function between negative infinity and x. Now we know that x can only exist between 3 and 6, so it's actually the integral from 3 up to x of our function, which I'll rewrite in terms of u, which is k 36 minus u squared du. That's what we need to integrate, and if we can do that, then we'll be on our way to working out this cumulative distribution function. Alright, so what I'll do is I'll just get the general integral of our function. So the general integral of k 36 minus u squared du is equal to k of 36u minus u cubed on 3. That is the integral of this function. So the way you can check that that's right is if you then differentiated it, would you get back to where you started? So 36u differentiated would give me 36, minus u cubed on 3 differentiated would give me 3u squared on 3, which would give me u squared. So that's kind of okay, definitely haven't made a mistake. So now what we have to do is evaluate this integral at the lower and upper bounds of what we're integrating between, and then subtract the two, and we'll have our function. So at u is equal to 3, what we get is k, which is 1 on 45, which we know from part 1, multiplied by 36 times 3 minus 3 cubed on 3. I'll just get my calculator. So 36 times 3 equals 108 minus 3 to the power of 3 divided by 3 is equal to 99. So we get 99 on 45 is the value of this at u is equal to 3. Now at u is equal to x, which is the upper bound, we get 1 on 45 times 36x minus x cubed on 3. So therefore, the probability that our random variable is less than or equal to x is equal to this upper bound, which I'll write as 36x minus x cubed on 3 on 45, minus the lower bound, which is 99 on 45. And I can just bring that together, and we'll say it's equal to 36x minus x cubed on 3 minus 99, all on 45. Now what we can do to make sure there's been no mistake in any of that process is we can check the upper and lower bounds of what we know are the values for x. So when x is less than or equal to 6, we should get a probability of 1 because all values must be less than or equal to 6. So the probability of x less than or equal to 6 is equal to 36 times 6 minus 6 cubed on 3 minus 99 on 45. Let's key that in and hopefully we get 1. So 36 times 6 minus 6 to the power of 3 divided by 3 minus 99 divided by 45 is 1. So that's a good sign. The other thing we can check is that the probability of x less than or equal to 3 is 0 because we can't have any values less than 3. And when you're dealing with continuous random variables, the probability of being exactly equal to a number is also 0. So we should get 0 here. So let's see. 36 times 3 minus 3 cubed on 3 minus 99 on 45. What does that equal? Let's have a look. 36 times 3 minus 3 to the power of 3 divided by 3 minus 99 is 0. 0 divided by anything will be 0, so good. So I'm comfortable that I haven't made any mistakes through that. So I'm going to go with this as our CDF. So now part 3 of the question asks us what is the probability that the life, the random variable, is greater than 5 weeks. So x greater than 5. Now notice that we've been asked for the probability of x greater than a number, but our CDF is the probability of x less than or equal to a number. So we can use that. All we need to do is say the probability of x greater than a number is equal to 1 minus the probability that it's less than or equal to that same number. And now we can use our CDF to work this out. So it'll be 1 minus, and we can insert 5 into our CDF. So 36 times 5 minus 5 to the power of 3 divided by 3 minus 99, all on 45. Let's key that into the calculator and see what we get. So go 1 minus bracket 36 times 5 minus 5 to the power of 3 divided by 3 minus 99 bracket divided by 45. And we get 0.1259 and so on. So that there is the probability that the life of the termite is greater than 5 weeks. So there you have that question. Essentially the key to being able to work through that is having an understanding that the cumulative distribution function is the probability that our random variable is less than or equal to x, and then knowing that to get there you have to integrate the function you're dealing with. From there it's fairly rudimentary algebra just to work everything out. The key is just to try and be careful not to make mistakes, and know that you can perform these checks to help you kind of make sure you haven't, accidentally done something wrong there. But once you've got your cumulative distribution function, you can then use that to work things out, both less than or equal to or greater than. The only thing you need to remember is that if you're finding the probability of greater than something, that's just 1 minus the probability it's less than or equal to something. So hopefully that's all clear, and tick boom.